Hello there, algebras. Welcome to your chapter 8, lessons 1 through 3 quiz review. So we're just going to be reviewing before our quiz. I just want to make sure that we go over all of the pieces that we've been using to get standard form, use the zero product law, and then generally solve quadratic equations. So we're just putting all of our pieces from these first 3 lessons together. So the first thing we want to remember is that standard form of a quadratic equation is ax squared plus bx plus c equals 0 form. So we're getting descending exponential order with our polynomial equals 0. So there is, of course, a point to that, which we will use with the zero product law, but we want to make sure we can easily get a quadratic equation into standard form. So I'm just going to do a couple with you. And then, of course, I want you to try a couple, pause it, and try them yourselves, see how we do. I'm going to start with number 2. And the reason I'm starting with number 2 is because we need factors with a 1 or greater, meaning the value in front of the x squared needs to be positive. So if I run into a quadratic equation where I don't have a positive x squared, I add it to both sides of the equal sign to get it to be positive. Well, if there happens to be something else on that side too, move it at the same time. So the opposite of a negative x squared is a positive x squared. The opposite of a positive 14 is a negative 14. And of course, I'm bringing these to the other side of the equal sign as well. And now what I'm going to do is these cancel out to 0. Bring down your equal sign. Now you go descending exponential order. Positive x squared plus 15x in the middle minus 14 at the end. There is your standard form of that quadratic equation. Let's do number 3. You have a positive x squared on one side of the equal sign. You have a 64 on the other side of the equal sign. Keep the x squared positive. Move the 64 to be with the x squared. So subtract that 64 from both sides of the equal sign. You got x squared minus 64 equals 0. There's your standard form. If you happen to have an x on the outside of the parentheses, just like any other number, distribute it throughout your parentheses. You get x squared minus 3x, bring down your equal sign, and 4. Now you can subtract that 4 over to be with the x squared minus the 3x. So x squared minus 3x minus 4 equals 0. All right, I'm going to pause it here. You guys try the others. I'll put my answers for those in red, and I will be right back. All right, how did we do? Check your answers in the red, 1, 5, and 6. Make sure you have standard form. And let's go. Now, the reason for standard form is that equals 0 on the other side of the equal sign. Because if that polynomial is factorable, then you factor it into its pieces. And if you know that those factored pieces are multiplying together to give you a product of 0, then you know that at least one of those factored pieces has to be a 0. And that's what we can then put in a t-chart. So we can set each of those factors equal to 0 and figure out what are the values of the variable that will make this 0. So that's what we did. The next step in lesson 1 is we had factored pieces set equal to 0. And so we used the zero product law. Okay, so this was the first piece of doing that. So let me look at number 8. I've already got 2 factored pieces set equal to 0. So I'm going to do the t-chart and I'm going to set each of these factored pieces equal to 0 in my t-chart. Now I've got 2 linear equations to solve. Nice and easy. I already know how to do this, right? So this is subtract 1 from both sides of the equal sign. You got 2x equals negative 1. So to get x alone, you divide both sides by 2. You get x equals negative 1/2. Over here, you add 2 to both sides of the equal sign. You get 3x equals 2. And then to get x alone, you divide both sides by 3. X equals 2/3. And then we put those answers in French curly braces. I always put them in numeric order, right? Smallest to largest. But those are both the answers for x that would make these factors equal to 0. And that would mean one of the two factors is 0, so that would mean the equation works out. If you look at number 10, all three factors have a variable present. So all three factors need to be in the t-chart and set equal to 0. 5x equals 0, x plus 2 equals 0, 7x minus 3 equals 0. And now each of these are mini linear equations to solve. So in the first one, divide both sides by 5, you get x equals 0, because 0 divided by 5 is still 0. Subtract 2 over, you get x equals negative 2. Over here, add 3 over, sorry, I wrote too fast. There we go, it's a little better. 7x equals 3, then divide both sides by 7 to get x alone. You get x equals 3/7. And of course, fractions are numbers, so we can get those as answers here. They're rational numbers. I get negative 2, 0, and 3/7 as my answers in the French curly braces. There were 1, 2, 3 answers because I had 1, 2, 3 variables. So I want you to try number 7 and number 9. I'm going to pause it right here. Try those, get the t-chart, get the answers, and let's see the difference between number 9 and number 10, where both of them have 3 factors, but there's a big difference there in their answers. So pause it here, try those, come back, and we'll look at their answers. Okay, what's that difference between number 9's answer and number 10's answer? Even though number 9 had 1, 2, 3 factors, all multiplying together to give me 0, only 2 out of those 3 had variables present. So when I took this factor of 2 that was out here, this GCF, and I set it equal to 0, I realized, 2 and 0, both numbers never going to be equal to each other. So what that means is that's not giving me an answer for x. There isn't an x present. There's nothing to solve there. That's just not where one of my zeros is, okay? But these could be places where my zeros are. So those two linear equations are what I then solve, just like the other ones, okay? One of the things to note is whatever the sign is inside the binomial, the answer is the opposite sign because you're moving that number over to the other side of the equal sign, right? To get that x alone. So that's one of the interesting things to note when you look at a binomial of x minus 2, you know, x equals negative 2. When those add up, that's 0. Opposite signs of what's in the binomial. That's going to be in your answers. Okay, and then last but certainly not least was the whole shebang, right? Quadratic equations equal to 0, get standard form, factor them yourself, t-chart yourself, get the answers for x. So I'm going to do a couple of these. Oh, how lucky am I that all of these are already in standard form? I'm just going to do a couple so that we can review types of factoring and that type of thing. Let you try a few yourself. I've done number 11 like 4 times during the notes. So why don't I do number 13? A little bit different than some of the ones I've done in the notes before. It's already in standard form, so that's good. It is a trinomial, so this should factor into 2 binomials. The n term is negative, so that means that my binomials will have different signs. What times what multiplies together to give me 90, but subtracts to give me 1, 9 and 10. 10 has to be positive because it is the bigger factor, so it has to have the same sign as the middle. And then because the n term was negative, that makes 9 the opposite sign, and that makes it negative. So now that you've got your factors, you t-chart, you set your factors equal to 0. And over here, I'm just adding 9 to both sides because, again, the opposite sign of what's inside the parentheses for my answer. Here, I'd subtract 10 from both sides. Opposite sign of what's inside the binomials for the answer. And my 2 answers for x are negative 10 and positive 9. How about number 15? And number 15 is going to be interesting because, yes, it's a trinomial already set equal to 0, so in standard form. But when I think of the factors of 9 that add up to 6, my mind immediately goes to 3 and 3. And actually, they both have to be negative because if your n term is positive, these have the same sign inside of them, and it is the same sign as the center. So I have exactly the same binomial. So when I go to T-chart and solve, set each factor equal to 0, this step has to be shown. That's the ZPL, the zero product law, being used. Then when I solve these, I get x equals 3 and x equals 3. Well, how many answers do I really have? 1. X equals 3. And that's all I have to put inside the binomials, and that would be all I'd have to check. Last one I'll do, and then you guys go ahead and give the other ones a try. I'll pause it and let you try 11, 12, and 14. I'm going to do 16. 16 is a binomial in standard form, set equal to 0. A binomial in standard form means I either have GCF or dots. So immediately you should be checking for perfect square minus perfect square because there's less perfect squares to memorize, so you should have your perfect squares memorized. I know 3 is not a perfect square. I know 12 is not a perfect square. I know x to the first power is not a perfect square. That means it has to be GCF. That's the only other type of factoring for a binomial. And then I think, oh yeah, 12 and 3, they're both divisible by 3. X squared and x, they're both divisible by x. So 3x is my GCF. Now I divide each term by my GCF. So since there's 2 terms in the original, the binomial, there will be 2 terms in the leftover. 3x squared divided by 3x, well, that's an x to the first power. And then negative 12x divided by 3x, that's a minus 4 left over. Now, this is a factor, and this is a factor. They're multiplying together to give me 0. So this is exactly the same. It's still a T-chart, right? You set each factor equal to 0. So 3x equals 0, and we're dividing both sides by 3, but 0 divided by 3 is still 0. And x minus 4 equals 0. And add that 4 over, you get x equals 4. So your 2 answers here are 0 and 4. Okay, so I want you to try number 11, number 12, and number 14. See how you do. You're lucky they're already in standard form, so that's one less step that you have to do. Pause it right here, give those a try, then we'll come back and check our answers. This is what's on your quiz. Make sure you're practicing this. See you guys in a sec. Okay, guys, how'd we do? Check your answers. Remember that when I have the same integer but the opposites of each other, positive and the negative, I use the plus and minus sign. You may write it as 9 halves, comma, negative 9 halves. That's it. You may do that if you want to. The order in the French curly braces does not matter, but I do them numerically, typically. Okay, so that's why you're seeing my numerics. They're in numerical order, but if you have 5, comma, negative 2 in your French curly braces, that's fine. Okay, this is what we're looking for. This is us solving quadratic equations by factoring. So we put all our pieces together, standard form, using the zero product law, and then getting our answers for x. Guys, ask me if you need anything. I am here to help, but otherwise, make sure you're practicing before you take your Chapter 8 quiz. Good luck. I'll see you soon.